Hey everyone, and a special welcome to all you IGNO aspirants out there. You've probably heard the term cost per student, right? It sounds so simple, but using it to judge how efficient a college is, well, that's a huge trap. Today, we're going to break down exactly why this idea fails, using a simple Q&A format that's perfect for your exam prep.
So, let's kick things off with a question that really gets to the heart of a major misunderstanding in education. Is a cheaper college automatically a better, more efficient one? I mean, it seems logical, but as we're about to find out, that simple idea is seriously flawed.
Here's our roadmap. We're going to tackle this by breaking down the 4 key reasons cost per student is the wrong way to think. Just think of these as the 4 pillars you can use to build a perfect exam answer.
Okay, so let's frame the central question we're really diving into today, the kind of question you might actually see on your exam paper. Why is taking a factory-style unit cost idea and applying it to a university or school so problematic?
The very first point for your answer, and this is absolutely crucial, is that education is not a factory. A factory's goal? Easy. Minimize costs while pumping out thousands of identical items. But a university's goal is to maximize quality and benefit society. And those things are way harder to measure.
And this brings us to a key piece of jargon you'll definitely want to use in your exam: technical efficiency. This is that business concept that's being totally misapplied here. Using this term correctly shows the examiner that you really get the core issue.
So, what's the first huge flaw in this whole cost per student logic? Well, it all comes down to a puzzle about what we're even measuring as the output.
Just think about it for a second. A car factory's output is easy. You can count it. 1,000 identical cars roll off the line. But what's the output of a university? Is it just how many students get a degree? The problem is, that number tells you almost nothing about what really happened.
And this is exactly why using the number of students as your output is so messed up. The real product is learning, right? But learning is invisible, and it's totally different for every single person. A degree from one college is not the same product as a degree from another. So any cost calculation based on that is pretty much meaningless.
Now for the second major problem, and this one completely flips that factory logic upside down. It shows us why, in education, cheaper almost never means better.
It really boils down to this. In the world of education, costs and quality are usually positively related. That's the opposite of a factory, where cheaper is a win. Here, spending more money often leads directly to a better result.
So why does that happen? Well, think about it. Better, more experienced teachers, they cost more. Modern, state-of-the-art labs, they cost more. Great student support services, you guessed it, they cost more too. All these things drive up the cost per student, but they also massively boost the quality of the education you receive.
This brings us right to our third argument, the very real, very damaging consequences that pop up when administrators mistakenly chase this false idea of efficiency just by cutting costs. Trying to be efficient by lowering the unit cost forces some really terrible choices. You end up hiring cheaper, less experienced teachers, you cram more and more students into a single classroom, you slash the budget for the library or the computer lab. You're not actually becoming more efficient, you're just destroying the very quality that the institution is supposed to create.
All right, our final argument shines a light on something totally unique to education that these simple efficiency numbers completely ignore. The value doesn't just come from the teacher. A huge part of it comes from the students sitting right there with you.
And this brings us to another must-have concept for your exam: peer effects. This is all about that incredible learning that happens when students interact with each other. You know, arguing a point in a tutorial, working together on a project, or just being motivated by some friendly competition. And here's the catch. These powerful peer effects, they work best in smaller groups. But smaller classes automatically mean a higher cost per student. So, in this case, a high unit cost isn't a red flag for inefficiency at all. It could actually be a sign of a really high-quality collaborative learning environment.
Okay, I know that's 4 big arguments to keep in your head under exam pressure. So to make it easy, just use this simple mnemonic: OQCP. Output is unmeasurable. Quality costs more. Cost cutting is harmful. And peer effects matter. OQCP. It's a super easy way to structure your whole answer.
All right, let's pull it all together for a quick revision. This next slide is the one you might want to take a screenshot of or just jot down the key points from. It's got all the key phrases you'll need.
So here's how you bring it all together in your answer.
Start by calling unit cost an inadequate indicator. Then tear down the factory logic by explaining the output problem and that positive link between cost and quality. Finally, you can hammer home how cost-cutting is harmful, while peer effects in small classes are actually beneficial. This all builds to your final verdict. Low cost in education rarely means high efficiency. It usually just means low quality.
And that leaves us with one last huge question. If cost per student is so flawed, how should we be measuring the real value of an education? Now, the answer to that is complicated. It involves things like long-term student success and contributions to society. But for now, you have everything you need to completely deconstruct this faulty idea in your exam. Best of luck.